Chapter 3 Tutorial 2. Okay, so we'll be going through 3 questions today, and these 3 questions are similar, okay, and they're similar according to the red highlighted part. Okay, as you can see, question 1, it mentions constant returns to scale. For question 2, diminishing returns to scale, and for question 3, increasing returns to scale. Okay, I hope you've read the questions already. If not, okay, please pause the video and go do it right now. Okay, I got a question for you. Alright, is returns to scale referring to the short run or the long run? Okay, everybody must take a vote. Okay, so is it short run or long run? Okay, for all of you that say short run, okay, go and bang the wall on your head, because returns to scale refers only to long run. Okay, I'm just kidding. You don't have to bang your head against the wall, but just remember that. Okay, when we talk about returns to scale, it is affecting our long run. Okay, and affecting exactly what in the long run? The long run total cost. That's right. Okay, so this is gonna affect the shape of the long run total cost. Okay, and we learned in the cost curves video what the curves would look like if they are experiencing exhibiting a certain kind of returns to scale throughout the entire production. Okay, so let's start with question 1 first. Okay, we'll be doing all the red parts first. Alright. Okay, I'm gonna show you question 1. Okay, when there are constant returns to scale. Okay, so you will need 2 graphs for this. Okay, you need one for your total cost, one for your average cost and marginal cost. Okay. Okay, so when they say that there is constant returns to scale throughout, that means it affects my long run total cost. Okay, so it's going to be a straight line. Okay, so why is it a straight line? If you hear constant returns to scale, just think to yourself, constant gradient. Okay, so the gradient is constant, right? There's going to be one gradient, that's it. So this is my long run total cost. Okay, so what is my average cost and my marginal cost going to look like if this is the case? Okay, we know that the average cost is calculated by drawing a ray from the origin, okay, to the long run total cost. But the thing is that the long run total cost is already a ray itself. So the ray is constant, so that means the gradient is a straight line, right? AC is a straight line because the gradient is constant. So it will look something like this. Long run average cost. Okay, and there's something else very interesting. So the marginal cost is calculated by, finding out what the gradient of the slope is, right? Of the long run total cost, but it's constant throughout as well. Okay, and it is the same as AC. Okay, so AC, okay, is also equals to long run MC. Okay, so it's the same line. Okay, let me explain to you again. Average cost, okay, is calculated by drawing a ray from the origin to the long run total cost. But now the long run total cost is already a ray itself. So that's why AC is calculated by just looking at the gradient of this slope. Okay, for marginal cost, is also looking at the gradient of this slope. But this is not a curve, this is a straight line. It's a linear equation, so that's why the gradient is constant throughout, and it is the same as my AC because it is the same ray. That's why my LRAC and my LRMC is going to look like this. Okay, so what I'm going to do next, I'm just going to add in a short run total cost, which looks something like this. Okay, with the point of intersection here. Alright, so if I'm going to draw this thing right down, okay, to the long run total cost, that means at this point over here, okay, there should be something going on, right? So what does this mean? Okay, as you can see, if this line is over here like that, okay, that means it's also a ray from the origin to the short run total cost curve. That means essentially we are showing a average cost curve. So that means this is how your average cost curve is going to look like. Okay, it's going to touch this part and it's going to come out. Okay, so this is my short run average cost. Okay, and for my marginal cost, same thing, somewhere here like that. Okay, yeah, it's as simple as that. Okay, and this is also the minimum point. Okay, because as you can see, okay, I've reached the lowest point of the short run total cost. I can't go any lower, so that's why this is also the lowest MC, this point over here. This is my short run MC. Okay, so if you look at the question, the short run marginal cost will always equal the long run marginal cost at the point of the minimum short run average cost. Very clear, it is true. Okay, if you want to test it out further, you can always go and draw another short run total cost curve, okay, which intersects at another point, and you will still realize that we will be getting the same thing. The curve will still be looking like this. Okay, so this sentence is true. Okay, so now let's go on to part 2. Sorry, question 2. Okay, question 2. Alright. same thing, I'm going to produce two graphs. Okay, so let's start with the long run total cost curves. Okay, so it says diminishing returns to scale. That means the gradient is getting smaller. That's right. So when the gradient is getting smaller, okay, so what happens is that we're gonna have something that looks like this. Okay. Okay, and I take that back. Okay, the gradient is not getting smaller. Okay, but just recall that when we're drawing our long run total cost, it goes something like this, right? Just remember that this portion over here shows increasing returns to scale. This part, the middle, where it's a straight line, is constant, and this part is decreasing returns to scale. Okay. When I said constant returns to scale, just think about constant gradient. It's just so that you can remember it clearly. Okay, but if you memorize it by this way, it's going to be much better. Okay, so take back what I said about diminishing gradient, because it's definitely not true. The gradients are getting bigger. Okay, but when you talk about diminishing, that means the returns are diminishing. So you realize that the more cost I spend, okay, the more cost I incur, the lesser amount of x I get. That's why it's sloping upwards like that. Okay, so this is going to be my long run total cost. Okay, so now how is the average cost and the marginal cost going to look like? Okay, do not be intimidated, this is very easy. Okay, so now let's tackle the average cost first. So I know that the average cost is calculated by drawing a tangent, a ray from origin which touches the long run total cost. Okay, let me show you what I usually do. Okay, what I'll do is I would be drawing dotted lines down. Okay, in the exam or when you're doing your own questions, please use a pencil so that it's not so messy. Okay, just keep drawing lines down. Maybe about 3 is good enough. Okay, so let me draw a ray from the origin to one of these points first. Okay, so I'm gonna draw a ray here. Okay, and I'm gonna draw a ray here. Okay, and I'm gonna draw a ray here. Okay, and you will notice something. Okay, what you should be noticing is that my ray gets steeper and steeper. Okay, so that means my average cost curve should be increasing. So you see this is very steep, right? So let me just mark a point over here. We got one point over there. This is not as steep as this, so that means my average cost should be lower, so it's somewhere here. Okay, and this is not so steep, it's somewhere here. So essentially we get a curve that looks like this. This is our long run average cost. Okay, and what about our marginal cost? Okay, marginal cost, same thing. Check out the points over here, right? Okay, so what we're going to do is we're going to be drawing tangents on these points. Okay, you're going to draw a tangent. Okay, let me use a different color so that you don't get confused. Okay, you're going to draw a tangent. Okay, tangent, tangent. Okay, so let's compare it with the average cost. As you can see, this line over here is steeper than this line, so that means my marginal cost is higher than my average cost. So I will mark a point somewhere here. Same for this point. Okay, because you can see my tangent is steeper than my ray, so that means it's somewhere higher. Okay, and as we go nearer towards the origin, the slope seems to be the same as my ray, but it's not. Okay, it's still a bit higher. So what you get is something like this, and you have our long run marginal cost just like that. Okay, so this is what it looks like. Okay, as for the blue part, okay, this is for question 2. Okay, I say again, this is for question 2. Okay, the blue part, please go and try it out yourself. Okay, I think the most important part is the red part, so that's why we are going through that. Okay, so this is what it should look like, and for practice purpose and to get this into your memory, let's do question 3. Feeling a little bit generous today. Okay, so let's do question 3. Okay, so I got two graphs, I mean, total cost, average cost, and marginal cost. X over here. Okay, so increasing returns to scale. Okay, remember this part? So it's gonna be, you know, curving this side. So I'm gonna draw my long run total cost looking like that. Long run total cost. Okay, so let's derive our AC and our MC. Okay, same thing. Let's draw lines. Okay, 3 lines will be good enough. Okay, so let's use purple for our AC. Right, at this point, okay, I'm going to be drawing my rays now. Okay, ray, and ray. Okay, as you can see, the rays are getting flatter and flatter. So that means at this point over here is quite high, and here it tends to get lower, and here it gets even lower. So my average cost curve is going to look like this. Okay, long run average cost. Okay, so now let's take a look at marginal cost. Okay, same thing. At this point, I'm going to draw a tangent. Here another tangent. Here another tangent. As you can see, the tangent is getting flatter and flatter. That means my marginal cost is getting smaller. That's right. Okay, so from here, okay, let's take this for reference first. Okay, this is high. Okay, and this is going to be lower, and it's going to be lower. Okay, and it will never be the same as my, okay, it will never be the same as the ray. Okay, so it's going to look like this. Long run marginal cost. Sorry. Yeah, correct. Marginal cost. Okay, so that's for these 3 questions. These are actually quite popular in prelim questions and even in exams. Okay, so I think the next time you see this question, you should be well prepared. Yeah, right.